In this video, I'm going to look at example 3 in section 1.8. Let me start by reading it just like usual. Let f of x equal x squared minus 1. In each case, start by finding the formula for the indicated function and then figure out what the graph looks like using your calculator or what you know about graphs of parabolas. Afterwards, describe the graph geometrically as it compares to the original graph of x squared minus 1. So let's start by looking at the original graph, that is x squared minus 1, and that should be a familiar parabola. So if I draw some quick axes here, I'll start by the y-intercept at 0, -1, and you can see that from the -1 in the formula. And then the parabola goes up because it's a positive x squared, and I'm going to label the x-intercepts as well. So those are at the two sides here. The one on the right is 1, 0, and the one on the left is -1, 0. And those 3 points will help us track what happens in the other graphs, where they move. Okay, so for part A, we have f of x plus 2. So we start with the formula for f of x. It's x squared minus 1. And then after that formula, we put plus 2. So you can simplify this one, and it might help. It's x squared plus 1. And that plus 1 will be the new y-intercept of that parabola. So I'll start by drawing the original parabola again, starting at -1. And now I'll draw a new parabola, and the y-intercept is going to be at +1 because of the plus 1 in my new formula. And so that y-intercept moved upwards. The parabola still opens up. It's still positive x squared, so it opens up. And the x-intercepts also moved upwards. So they moved to the points I'm labeling now. And so everything shifted up. The x-intercept on the right is 1, 2, and the x-intercept on the left is -1, 2. So the y values changed. Okay, so I can describe this now, and I will call this transformation a vertical shift by 2, because it all changed in the vertical direction. All the y values changed. And so everything went up by 2. It's a vertical shift by 2. Okay, let's go on to part B. Part B, we have f of, and then inside the parentheses, it's x plus 2. So we're changing the inside of the formula. So that'll be x plus 2 in parentheses squared minus 1. And in this case, it's not really useful to FOIL it out. So I'll just go ahead and tell you in a moment what the graph looks like, and then I'll justify it. So the original graph still starts at the y-intercept of -1. It still opens upwards. I'll label those 3 values, or mark those 3 crucial points again, the y-intercept and the 2 x-intercepts. And now what I claim is that the new graph is going to be this graph shifted horizontally to the left. It's a little surprising, so I will justify it for you in a moment. But each of those 3 points I'm going to claim went to the left by 2. So I'll draw the graph, I'll draw the points, and then I have these arrows showing you where things moved from. So let me show you one of the points that I claim is correct, namely the point on the left here. I claim it moved to the left by 2, and so that means it should have the x-coordinate -3 and the y-coordinate 0. That's my claim, and now I'll justify it. Let's plug in -3 to our formula. -3 plus 2 squared minus 1 equals -1 squared minus 1 equals 1 minus 1, which is 0. That's the correct y value that I claimed. I can show you another point like that as well. So the one on the left here should be -2, -1. Is it? Well, let's find out. We'll plug in -2 plus 2 squared minus 1. I'm plugging it into the formula for f. That gives us 0 squared minus 1 which is -1, which is what I claimed was the right y value. So both of those points move to the left. And now I'll describe the whole transformation as a horizontal shift to the left by 2, or horizontal shift by 2 to the left. You can say it in either order. Okay, so that's part B. You can already guess part C will be similar, but I'll go through it, and maybe I'll go through it a little bit faster. But this one is f of x minus 2 on the inside. So that's x minus 2 inside parentheses squared minus 1. And I'll still start with the original graph, the original parabola, and the 3 points that we kind of keep track of, the y-intercept and the 2 x-intercepts. And now I claim that those are going to move to the right by 2 this time. So the shortcut, when I change something inside the parentheses, is it moves kind of the backwards direction from what you expect. So when it's x minus 2 on the inside, it goes to the right by 2. So these 3 points that we keep track of moved to 3 new points to the right, and then I try to draw a parabola through those 3 points. And again, you can double check those points if you want, the same way we did in part B. You can plug one in and see what you get. So for the y-intercept, you should get 2 comma -1, and it's pretty easy if you plug in that 2 to the formula for f to see that that comes out right. 2 minus 2 squared minus 1 will be 0 squared minus 1, which is -1. That's what we thought. Okay, so I think we're ready to describe this shift now. This is again a horizontal shift, but this time it's not to the left, it's a horizontal shift to the right by 2. And I'm underlining right because that's the crucial difference with part B. Okay, so let's move on to part D, 2fx, f of x. So let me write that down here at the bottom. Part D, 2f of x. And I'll start with the formula again. This is 2 times parentheses x squared minus 1. And this time I will FOIL it out, or distribute it rather, because I will use this formula to see what the graph is. The y-intercept of this formula should be at -2. So I'll start with the original parabola, which has a y-intercept at -1. And again, I'll label the y-intercept, at least with a dot. And now I'll draw the new y-intercept, which is at -2, 0 comma -2. So that's 1 point. Let's think about the other points too. The x-intercepts, I claim, are not going to move. Because if you plug in -1 and +1 there, you'll get 0 for the new formula, just like you got it for the old formula. So the x-intercepts don't move, and I can draw my parabola through those 3 points. And what happened is the y-intercept stretched downwards. The x-intercepts didn't move at all. And then points above the x-axis got stretched upwards. So everything stretched away from the x-axis. We call this a vertical stretch by a factor of 2. And it's not a shift because everything moved in different direction, away from the x-axis. So down if it was below the x-axis, and up if it was above. Okay, let's do part E. This is f of 2x. So now the 2 is inside the function. You apply it before you plug everything into the formula. So 2x squared minus 1. Maybe I'll rewrite this as 4x squared minus 1, but it's the minus 1 that is, again, most useful for me here. So that tells me where the new y-intercept is. I'll start with the usual graph of the parabola. And so that still has the y-intercept of -1. But now my new graph, the one that I usually draw in red, is also got a y-intercept of -1. So I'll label that with a new point. And now what about the x-intercepts? That's what's going to change in this problem because we're changing the input of the function. That means we're changing the x values. And so the question is, which way do they go? Let's set up an equation to find the x-intercepts. 4x squared minus 1 equals 0. We get 4x squared equals 1, and eventually x equals plus or minus 1/2. So those are the new x-intercepts. And I'll label those. So the old ones I put in black, and then the new ones I put in red, and they're coming in from where they used to be. So they used to be at -1, 0 and +1, 0, and they went to -1/2 and +1/2. And so now I can draw a parabola through those 3 points, and you can see the way I've drawn it. It does look steeper, but more importantly is it's coming in a horizontal fashion. So I described this transformation as a horizontal shrink or horizontal squish or something like that by a factor of 1/2. So it shrinks to 1/2 as much as it used to be, or as big as it used to be. And it's 1/2 because we changed the inside with multiplying by 2, and things kind of get reversed when you change the inside of a function.